Hi everyone. In this lesson we'll talk about the fundamental theorem of calculus, which is basically the kind of underpinning theory behind calculus and one of the big results. You've probably realized it intuitively, but the essence of it is that X-rays and time lapses are opposites. So it kind of makes sense. We thought of X-rays as splitting apart and time lapses as gluing together. And so the idea behind the fundamental theorem of calculus is that you can split apart and glue together. They're opposites, and you can kind of use them to make problems a little bit easier to solve. Let's take a look. The first part of the fundamental theorem of calculus is essentially that instead of having to add up things manually, you can sort of use the endpoint. So if someone gives you a series of steps to glue together, like 1 plus 3 plus 5 plus 7 plus 9, if you realize that those steps actually came from some pattern that you already know about, like a square, you can just shortcut the whole addition here and just jump right to the square. Now in this case we're going to use a plus 1 because these are integer steps. And so if someone asks you what's 1 plus 3 plus 5 plus 7 plus 9, you can say, well, that last step would have taken me from 4 to 5. That means I built up a 5 by 5 square, and that's what it is, 25. So you can sort of sidestep all this manual computation here and hop right to the end result. And the next result of this also is you can even do a partial computation. So if someone says, well, what's 5 plus 7 plus 9? I mean, that one's, not too bad to figure out, but you can figure it out this way too. You can say, well, the whole square would have been a 5 by 5. We kind of removed out this beginning part, the 1 plus 3. So you subtract it away and you get 25 minus 4, or 21. So the idea here is that you can sort of use the original shape to make it a lot easier to compute these definite integrals, because a definite integral is just trying to manually glue together the shapes, and the indefinite integral is sort of the original shape, right? Where did it come from? So the one element of the fundamental theorem of calculus is that, well, we can actually use the original shapes to make this gnarly computation a lot easier. Now the next insight about fundamental theorem of calculus, and it's more of a kind of mechanical insight, is that if we have a series of steps and we want to find out what function made them, we can use our vase analogy. So remember, we had our vase dealer, our antiques dealer. What he would do is he would take vases in the back room and break them and look at the shards and try to match up the shards that he had broken with the shards that you brought in. And if you brought in some shards that matched the ones that he had broken, he'd say, oh, I already know what vase that came from. The second fundamental theorem of calculus basically allows us to do this. It says that if we take some steps and accumulate them, and then break apart that accumulation, we'll basically get the same steps that we have now. So what that means is if we can find something which, when broken, returns the steps that we have, well, that was the original. And so it kind of gives us the permission to work backwards. So a lot of times you don't need to try to manually add things together. You do a little bit of trial and error, and you get better at it as you practice. But you do a little bit of trial and error, and you see that if I can take the derivative and equals the steps that I have, well, then I know that was the original. So those are the two key insights behind the fundamental theorem of calculus. Happy math.